Okay, welcome to your third word problem tutor training video. This one has to deal with different types of rates. So we're going to first look at working together rates. Here's an example problem. The new employee at Pete's yard service can mow a large yard in 5 hours. Pete can do the same job in 3 hours. So already we have the employee and Pete having different rates. How long would it take them to do the job together? So some students might be tempted to average these. That doesn't make a lot of sense because they should be faster together, right? Not slower than Pete would be alone. So you want to first make a fraction. So let's look at first the employee. So the employee gets 1 whole yard or job done in 1 set of 5 hours. So this would be his hourly rate. So he gets 1/5 of the job done in 1 hour. Okay, Pete's ratio is that he do 1 yard, large yard, in 3 hours. Or you can consider it that in 1 hour he's able to get 1/3 of the job done. And here we're going to add them because they are working together, and that will give us a total rate. So 1 yard, and what we need to know is how many hours that takes when we add them together. Sometimes the variable will be how long does the employee take, or how long does Pete take if this is how long they work together. So the variable might change, but you can use this setup for these problems with always a 1 on the top because you're getting 1 job done. It is A is the employee and B is Pete, and then 1 over the time together. So lots of fractions involved. If they have ways that they like to use, like the magic eraser we talked about before, multiplying by common multiple. There's ways you can get rid of the fractions or you can leave them. Let's go ahead and solve this one. 1/5 plus 1/3 equals 1 over x, just writing it without all the words. And then on the left side, we have just numbers. We don't have any variables, so we can combine those as like terms. We can always get a common denominator of 15, so we have 3/15 plus 5/15 equals 1 over x, right? 8/15 is 1 over x. And it feels almost like you're done because you have a variable on one side and you have just a fraction on the other, but the variable is in the denominator. And there's different ways you can think about that. Maybe multiply both sides by 15. And then both sides by x, different ways, like we could cross multiply. So eventually we could have 8x equals 15, divide by 8. And if your last step looks a little different, that's okay. So we ended up just flipping the whole thing. Right, x over 1 equals 15 over 8. You can think about that as well. So final answer, 15/8 of an hour, if you want to write that as a decimal, it'd be almost 2 hours. Or even as a mixed number, 1 and 7/8. So on these work rate problems, you can use this formula, depending on which variable you're looking for. Okay, let's look at distance and rate. So first, we're going to compare Rick and Mark. Rick and Mark drove boats on the lake, sailed boats maybe. Drove doesn't really make a lot of sense. On the lake for the same amount of time. Okay, so again, we're looking for data, same amount, that's going to be important. Rick's average speed, so this is a Rick speed, was 12 miles per hour, and Mark was going faster. He was going 14 miles per hour. Mark traveled 9 miles further than Rick, which makes sense because he was going faster and they traveled for the same amount of time. How long were they both on the lake? Okay, so we're trying to find the time. One thing with word problems is that it's really helpful if you can find a good way to organize your information, right? Like finding the data and writing the unknown. But tables help a lot of students, and especially problems like this, which you really have 2 variables going on. We have the time. We don't know how long they were out there, but we also don't know how long they traveled or how far they traveled, the distance. We don't know that either. So if we can separate those two ideas with the table, that's going to help a lot. So what I'm going to do is I'm going to make a little table, and I'm actually going to show you two different ways that your students might make the table, and different ways that you can help them out with this. And we know there's a formula, right, for distance and rate and time, which are all involved here. So we're going to split that up in our table, right, for Rick and Mark. So we're going to have their rate, their time, and their distance in our columns. Okay, already looks super organized. Rick's average speed, so his rate, was 12 miles per hour. Mark's was 14 miles per hour. We know from the first sentence that they traveled the same amount of time. We just don't know what that time was. So I'm going to put T and T there. Okay. And now distance is also unknown, but we can put it in terms of the known variable, well, of the variable T. So we're going to do our formula. Distance equals rate times time. So 12T. Okay. Similar for Mark, except he's got a different distance. The M for Mark is 14 times T. Okay, as is, that doesn't really help us, but we have a piece of information that we haven't used yet, which is the 9 miles further. So if I just say, okay, Rick's distance and Mark's distance, those are perfectly equal. That's not true, because Mark went further. So in order to say that these two distances are equal, I'm going to have to give Rick a little help. Right? I'm going to have to say, if I had added 9 to Rick's, it would have been equal. Now I can say they're equal. Or even here in my table, I could have written, instead of 14T, I could have said 12 times T, and then the 9 more to make that equal. The 9 more. Right, Mark's distance is 9 more than Rick's. So now I have an equation, one variable. Oh, I can solve that. So I'll subtract 12T. 9 equals 14T minus 12T, which is 2T, and divide by 2, and my time was 4.5 hours. Nice long time to be driving boats. Or you can put 9/2 hours, or 4 1/2 hours too. Okay, one word of caution, because in this statement it says that Mark traveled 9 miles further than Rick. A lot of students will be tempted to add the 9 here, right? But that would be giving him an additional 9 miles, and he's already 9 miles ahead. So we have to give it to Mark to make these still equal. So be careful of that. All right, let's look at a different way, because some students will interpret the table in a different way. So let's still set it up with Rick and Mark. R, T, and D. Okay. And the rate would still be the same, and Mark's rate will still be the same. But what differs here is they may use, instead of the variable T for time, they might use D for distance. So let's say that Mark's distance is just D, right? And we know from the second part that Rick's distance is just D. Mark's distance is Rick's distance and an additional 9 miles, right? Plus 9. And they might go backwards to time and say, okay, well, how do I figure out the time using D as a variable instead? And you're actually going to do this on your assignment as well. You're going to walk through it once with T as the variable, and then once with D as a variable. So let's go back to our formula here. If distance equals rate times time, then we can solve for time, and time is equal to the distance divided by the rate. And so we're going to take distance for Rick. Ooh, there's an airplane outside. And divide by the rate. Right? And then we're going to do the same thing with distance plus 9 over 14 for Mark. And we know from the information that we're given that the time is the same for them, that the two times are the same. So I'm going to set that up as distance over time, distance over rate is equal to the other distance over rate, because we know the times are the same. Now this is one that I can solve. I can cross multiply, and I'll get 14d equals 12 times d is 12d. 12 times 9 is 108. Solve for that by subtracting 12d, I get 2d equals 108, and d equals 54. Okay, but because these students set it up looking for the variable d, that's what we found, but the question was actually asking for time. So if we set it up this way, we then want to just finish by finding the time. So we can use the time in our table, right? We don't know time, but we know the distance is 54. We're going to divide that by 12. Now if we did 54 plus 9 divided by 14, we get the same thing. And we still get 4.5 hours. So it's a different process, a little bit more roundabout way to get there, but it works. So whichever one makes more sense to the student, you go with that and you help them where they're at. Alright, that's rates and all our work problems for this set of videos. Well done, go ahead and do the assignment.